Just apply pressure gently and hold it there. Yeah, it's coming. And we do have another challenge, and this time is a white Mercedes EQC. We've done EQCs before, and this one seems to be an interesting one because it drives, but something is not right. This is an electric car, by the way. Something is not right with the traction battery. This is not an auction car. This is not accident damage. Apparently, the problem started when the car sat for a longer period of time. And it is to do with the traction battery. What it is, let's put it in a workshop and see what it's all about. Ready comes on. However, we do have a malfunction, but we do have drive. Hello from OGS Mechanics and OGS Mechanics Hybrid and EV. I'm George, and here in our workshop we fix cars. All types of cars, but mainly specializing in hybrid and EV vehicle like this. Stay close for interesting repairs translated in videos. So let me tell you what it's all about. We do have an error here, malfunction, but here's the problem. The battery is fully charged and it shows 94 miles range. It doesn't look right. This car, those cars, they cannot have 100 miles range with a full battery. So here is the first clue. What exactly is going on? Why with a full battery it has 94 miles range? Not right. Let's get it scanned because we've done already some checks, and we've decided that we have to film this because apparently it's starting to be common with Mercedes, and the design on this traction battery is definitely different than other vehicles, and for definite interesting. So while Lal is scanning the car, let's get some more facts about the car. So this vehicle has covered 104,000 miles, which, if you think about it, is not a high mileage. Again, no crash, no unknown history. The car literally been sat and this problem came on. Let's see what it's all about because we are getting some data. So what do we have here, Lal?
Some communication fault and the battery module voltage also impulsible.
Okay, so before we show you this, let me explain you a bit. Well, Lal actually is going to tell you about this Mercedes because if we look at it, it's not the first one. Apparently they all run similar layout.
Yeah.
So what it is?
There is two battery combined together. It's a one.
Two battery. To make it easier, understandable, we make a draw here. So the way this Mercedes architecture works, and again, it's not just the EQC, probably we're not sure whether all of them, EQA, EQB, EQC, EQS, whether they all run same architecture, but we've seen it in a few cars, in a few Mercedes. Yeah. So basically, the battery is made of two batteries connected in parallel or in series?
Parallel.
In parallel. In parallel for?
More range.
For more range. And then if you think about it, what we have in the dashboard, we have 94 miles. What do we expect range on those cars? Upwards of 200.
200.
So basically what we have there is actually range from just one battery, one or two. We're gonna figure that in a second. So we know we have two batteries, and then by the looks of it, we have range from a single battery. Let's go back to the scan to try to understand better the dynamics of the
battery.
We have two batteries in total that they make one battery. Each battery, it has one control unit, and then both control units, they report to the, let's call, master control unit. Hope it makes sense. And now if we go back to the diagnostic, so where we are now, which module?
EVA, module A.
So we are in module A. Okay, perfect. So let's stick here for now. So we are in module A. We put one. So in module A, what do we have there? So the stats that we're looking are literally those. The charge.
State of charge 10%, state of health 100.
And the battery is quite balanced.
20 milliwatt.
So let's stick to this. So 10%. So we know our BMS one, it's here. 10%, yeah? So this is what we have in our BMS one. Do we have error codes here?
Yeah.
What's the error code?
The voltage, impulsible, and the module. Can you go back?
Yes. The hybrid voltage battery module
must be replaced.
So we'll stick and we'll come to that in a second. So it says that the battery module has to be replaced. Bear in mind. Let's go forward.
Then battery pack 2.
So in the battery pack 2, so the battery pack 2 is 95%, 10 millivolts. Okay. Now here's going to be an interesting one. So the charge here is 95%. So all of a sudden we see a big discrepancy because those batteries are connected in parallel. They should go up, down. So charge, discharge together, keeping the balance. Do we have error in here?
Yeah, there is only the communication faults.
Communication, so nothing really relevant.
Communication with the drivetrain has malfunction, impulsible data received from
You know what I want from you, Lal? Can you tell me the battery, the cell voltage here? 3.4, yeah?
Yeah.
So we know at this level, the voltage 3.4, 6
voltage.
6. And then the total voltage at this?
331.50.
331.
Yeah. 1.50.
We'll round it to 331. So we know the BMS, the battery 1, at this state of charge, we have 3.6 per cell and a total of 331. What do you have in the BMS 2?
Total voltage 400.
Yeah, let's round it here.
Cell voltage 4.16.
4.16. So straight away we see a difference. We've scanned BMS1, BMS2. BMS1, it says that the control unit has to be replaced. Although the battery is balanced, we have no record. What is the main BMS reporting? So the state of health, it shows 47. I'm not sure how relevant it is. And 29, again, since this is monitoring both of the units, it's a bit strange. We have to understand whether this data is actually clear. But when it comes to error codes,
voltage impulse.
The voltage of the hybrid is implausible. The system function is restricted. So what the master, if we can call it a master, I'm not sure whether Mercedes call it a master, is reporting obviously the difference between the cell, and is also reporting there's a restriction, as obviously as they are, they cannot operate. Now he has to be in charge and direct communication with BMS1, BMS2 to charge and discharge the battery. Let's plug in the dealer tool because we already done some checks to try to understand what is going on in here. Until Lal is going to connect the dealer tool, we're going to come to the point that we made it so many times. What should happen with a vehicle when it goes in storage? Or what should never happen? What's the main aspect for an electric or hybrid vehicle when it's going to be sat for a long time? What has to be paid attention? Lal?
Yes.
What is the main thing for electric and hybrid car when they go in storage?
Sorry?
An important aspect about the batteries
Okay.
on electric and hybrid cars when they go in storage.
Storage.
Yeah, what's important with the charge on those cars? An important, so if you, if you leave a car sitting for long, what is important?
Voltage.
Charge.
Charge fully.
Don't you ever leave it with low charge, because that's what is going to be triggered. So what this tells us, when the battery, when the car was left, it was left with low charge. And it doesn't take long, at low level charge, it doesn't take long before the battery becomes imbalanced. And not the battery, because what we see, the module A is fine, is balanced, the module B is balanced also, but for some reason, they become imbalanced between them. We don't know, sometimes it happens. That's why it's always recommended, not low, not high. What sort of charge?
Average.
Medium. So 40-60%. So 40-60%, the car goes in storage, it's going to be safe, the battery is not going to get unbalanced, and it's going to avoid problems. Now, let's see what the manufacturer tool says. So we are connected with the dealer tool. I hope this is interesting, because we're going to debunk everything in terms of technicality, how it works. And the Mercedes tool refers to all this differently. So which is BMS1, N82?
N82 3.
So this is N82, 82, yeah?
Yeah, 82.
82-3.
3.
The master? N82?
2.
-2, yeah?
Yeah.
And this?
4.
N82-4. So putting those names, so it'll be easier to understand what we have here. So of course we are going to have same error codes, yes?
Yes, same.
So this is, which one is this?
Master.
This is the master, the N82-2,
Yeah.
correct? Scroll up to see that. So N82. Let's go to N82-3, the one that we having the issue. So we are now connected to the BMS1, the module where we have low charge. Let's see what the Mercedes tool does. So we have this error code, and then if we click this test button, it's gonna take us to a procedure. What this procedure says, voltage of circuit. So if we get into the next stage, which it says the whole process is going to take 180 minutes. Now, the reason that I don't want to do it is because we've done it already. And that procedure, it says leave the ignition on, but there's a precondition of that. The N82-4, this battery, the charge should be low. In theory, leaving that procedure to run, after 180 minutes, the car should be put on charge, and both of the batteries should charge together. Guess what? It doesn't work. It doesn't work. And what do we do here now? Because we are going in loop with that procedure. We've done it 2 times, yeah, 2 or 3 times.
More than 2.
Yeah, every time 180 minutes. So if you do the math, more than a day we spend, and then not even that, we spend more time because We discharge the battery and then wait 180 minutes, put the car on charge. The car is going to charge, and it's only going to charge the BMS2, the N42.4. This one is going to stay exactly the same position. And then we have to go again, discharge it, and it seems that whatever we do, we only get to work on this module. This is stuck here. Now to me, looks like a software glitch. Looks like a software glitch, and everything happened because when the car was stationary for longer, it was low charge, it became unbalanced, and it doesn't take long. Don't forget those batteries, they're highly sensitive. If they notice difference between the cells at the cell level, not at the module level, it'll stop, will disconnect one battery. As a part of the diagnostics, we are connected to the master control. You need to try to understand the condition when the error has been triggered the first time, where the cell voltages in the hybrid battery error code has been triggered. Apparently, in the N83.3 was 3.7, N84 3.42. So that's a very low difference to trigger an error code. So indeed it was 347. So what is here clear? So we have now 346. So it was on 10%. Both of them were on 10%. And a very slight difference. The car was put on charge, only one start charging. To me, it looks like a software glitch. I don't see the battery being so imbalanced to trigger that, but they might be overly sensitive on things like that. Yeah, now the question mark, how are we gonna fix this? Procedure by the tool has not worked.
We before did one hybrid same like this. We charge the battery separately.
So that will be an option for us to charge the battery to see whether, if we take this here, will it automatically clear the error code? Because remember, we have drained this up to here, error code hasn't drained. So did it store a permanent code? Here is a big question mark. Now the other interesting thing, we could replace this, could we not? It's not available for that. So it could be that the error code that is triggered, it cannot be clear. Now we have this error code here, don't remember we have another one here. So how will we be able to clear the error codes even if we equalize the batteries? That's going to be something interesting.
Yeah.
But for definite, our plan is to resolve the battery, because whatever we've tried on the car has not worked with the manufacturer tool.
It's not bad.
So let's see exactly what is happening on this EQC.
Yeah.
Interesting, isn't it?
Yeah.
Is it overly sensitive? Why is triggering this? I'm pretty certain if this would be here, but still the condition, if we think about the difference in the in the modules, it was not great according to the data when the error was triggered. Anyway, I don't think anything else we have to cover at this moment. The plan is to take the battery off, charge it, and see how we're going to handle the errors in the control units, because that might actually be a bigger problem than the charging. Charging, obviously, it is a comprehensive battery. It will be a comprehensive process to get it charged. But what are we going to do with the error codes? We have a plan, but we don't have the full plan yet. Let's get the battery. Let's get the EQC up.
Drop the battery.
Yeah. Have you seen here? Looks very nice. The front boot. Only there's no boot. It looks very pretty, isn't it? Oh, you take it off, doesn't look too pretty anymore. It's good at the... So some components in here, they locate the heater. This is the... Two heaters? Yeah. Oh, look at that. Very comprehensive. The motor looks big. The inverter is accessible. And then we'll see more from underneath. So we've stripped quite a lot of the components to get to the battery. We have disconnect the coolant. We've now disconnect the power cables. We even disconnect the battery, and we are ready to drop it off and get into it to see exactly. Yeah. If you drop it, I'll check here, Lal. If you check that side.
Down?
Yeah. And that's how the EQC battery looks like. We have some memories with this. It's quite a comprehensive unit. So, as we said before, this is not a battery. This is a battery made out of two batteries. So in here, there are in total 6 modules. Now we're gonna put the battery in our battery bay and start stripping, get deep into it. Ooh. Our plan is, first of all, where is it? Where do we start from?
Yes, cleaning.
Yeah, clean it. Probably that'll be a good starting point. We have dismantled the battery quite a bit. We have removed the cooling maze, the covers, the connectors. Now, the bigger task to work on this battery is take those 2 covers off because they are sealed with hard silicone, and this is going to be a mission. We've done it before. We try a slightly different approach because here it's very, very tight, and this is aluminum, a massive cover, and the silicone is some hard silicone. Now, we use a softener for the seal. Let's see if this is going to make a difference. So our plan is to lift up the side, and then hopefully gradually it's going to come undone. And we're going to use some of the small tools like this. Let's see. What's the plan? We have 3 of those. So we're going to try to lift it up from 3 places. Gently, guys. Just gently apply pressure. Just apply pressure gently. And hold it there. Because the surf, yeah, it's coming. It's coming. Just hold it, yeah? Gently, don't apply too much. So I hear it. It's gonna bang. Yeah, it's coming. This is the first part. Now here, how the inside of an EQC battery looks like, and only one side of it. And we have one control unit, second control unit, and we're missing the third one. No, actually, hold on. Here, the 2. Slaves. Hold on, but why do we have 3? This is the sleeve for the pack then. Exactly. So the way it works, yeah, now we figure out. So each module, it has one of those control units which reads the data, the voltage and temperature, and then sends them forward. So I know this is definitely a main one, but we do expect, so those are sleeves. So how many modules? We have 6. We have more than that. Why do we have 3 here? It's a bit an interesting layout. But the main one, which was quite a bit of a job, is good at is out. So yeah, more preparation, and you have to take this cover off. So quite significant work has gone through to try to peel off the cover from the battery, obviously to cut really the sealant, which we managed to do. And it is the time to uncover the battery. Oh, this is quite heavy. Yeah. Only the cover on its own is quite heavy. So yeah, quite a thick surface of sealant. Anyway, that's done. And here, how's the EQC battery looks like, EQC 300. How many kilowatts this battery is? 80 and 652 kilo. So those are the stats. 80 kilowatts hour battery. Now, let's try to understand the structure, because we have a battery in theory, but we have two batteries. So the way we look at it, we should have 6, so 2, 4, and here there should be 2 modules, one on top of each other. So we have one control unit here and another one here. Can you check the part number, Lal?
This one A2939006500.
That's the one. Yeah. So those are exactly the same.
Same. To interface.
Okay. So those could be the controllers from the individual batteries.
Yes.
So again, what we have here is quite an interesting technology. So although all these are the same casing, we have 2 individual batteries connected in parallel. Now, I'm not sure. So the way we have it, if I well remember, there should be 2 on one side with one of the modules and 2 on the other side with one of the other ones. So either the top or the bottom. And then we should also have the third battery control unit. So if those are the same number, they could probably serve the batteries. So we have 2, how should we call it? Batteries. Do we call it batteries? They are batteries, yeah. If you think about the 3 82-3, 82-4. So let's say module 3 and module 4. So we'll have it easier. And in our situation, the module 3 was lower on charge. Lower module 4 is the one that operates still okay. And our problem is that following the procedure from Century, we said that we were discharging the module 4, that it was operating fine. So discharging and charging, so the car was drivable. However, in no possible way, following all the instructions, we could get the module 3 to recharge. Let's do a test, Lal, to try to understand. So understanding the components, so we know here we have individual. Where is the 82.2, the master?
Maybe outside.
Maybe it will be outside, isn't it? So again, we have a module for each of those modules, module 3 and module 4. And there's another one, a master, like controls those 2. So get the data and then communicates with the rest of the car. So what we're trying to measure is the battery. I'm not sure exactly how it's going to work. Hold on. So will it be those 2? Okay. So 331. Do you remember? Yeah, well, actually it was 331, the module 3.
Module 3, yeah.
So what we're measuring here is actually the module that is discharged. Let's go to the relays on the other side. So 331, do you remember how much was the module for?
399 point something.
399.
Rounders.
So we try to, no, is it that? No. Yeah, 399. So basically what we are measuring here is output from the battery that goes into the relay. Obviously the relay then put all the energy out whenever is required. So 399 versus 331. Okay, but which are the, let's do the individual cells measurements. So let's see the top one. So 149 here. Can you get to the bottom one? I think I'm here. 124. So 149, 124. So again, in here we have two modules. We know the one from the bottom is the one from the module 3, which is discharge. Can we check this? 82. 99. So this side, okay. 124. 149.
So that's
So this side, together with the, which one we said? The lower one.
Yeah. Module 3. The lower one.
So the module down with those two, they're together forming the module 3, our module which is discharge, and it is controlled by those two relays. Now, our plan, what is our plan?
Recharge.
Yeah. Because no matter what we've tried, we couldn't get this bank to recharge following. And for that reason, we want to do a manual recharge. We're not certain whether this is just a glitch. Now, this battery is not below minimum level, so it makes no sense why it doesn't recharge. Hence, we don't have even some error codes. You know what, Lal? I would like to... So we definitely want to recharge. I'm just thinking, is it anything else that we are missing here in this, or is just a software glitch? Knowing that the car was running fine, knowing that we don't have any other errors, just the cell imbalance. Because we know the cells, at the cell level, we don't have an imbalance. We know that for certain. So to me, it might be that we have a glitch. So we are now connected to the battery. And we are going to read stats from here, stats from there, and make a plan. To me, this looks very interesting what we're trying to achieve here. So, Lal, let's see what we're getting out of it. So in theory, we connect through this interface, and then we have to go through each of the controllers. So the system, this we suspect is going to be the
main
master. So the one that sits on top on each one of them. And here, it should be the 1 and 2. Versus 399. Now, here where it gets very interesting. So we know the module 1, which is, we call it the 3, yeah?
Yeah.
Within that, the 3, which is this one, yeah?
That one.
Okay. So this control unit has an error code of imbalance. However, we have no imbalance into this module on its own. So it's 20 millivolts, which is absolutely fine. Is it reading the imbalance because it sees the data wrongly from the other side, which is different state of charge? But the problem, even when we had low state of charge, we still had exactly the same issue. My theory is that for some reason, this has registered, which I call it a software glitch, I believe. Because if you think about it, not even the Mercedes procedure didn't work. I believe there's still some things that still have to be seen and updated, because it doesn't make sense why has triggered this error code. We have no imbalance in the battery. Now, what is our plan, Lal?
Just recharge this side.
Recharge this side. So bring it to the same voltage.
Yeah.
And then here it gets interesting.
Maybe programming.
Will the error clear automatically?
Or we have to clone.
We have a plan. We have a plan. If this doesn't clear automatically, what we're thinking of, use this guy over here and get the data out of it, because the data in that control unit is absolutely fine, and that side of the battery operates fine. and it's good that it is same part number. So in theory, it should be pretty much same software in it. Is this interesting?
Yeah.
It's definitely also for us. Yeah, it's still a mystery why it has triggered the error, because we cannot physically see any problem in the battery. So anyway, we do have the panel. So we need to charge this side of the battery to 399, and then from there we have to resume the testing. So let's set it up and get it going. Also, while we gonna do that, what are we going to do? Can you go back to the section that will be monitoring closely during, yes. So here, and then place temperature. So how many sensors, how many temperature sensors we have? 32 temperature sensor. Yeah. So across this side of packs, we have 32 temperature sensors, which we're gonna monitor closely, making sure that the battery is stable during this charging process. So let's see how we're getting on. Everything set up to start the charging process. If Lal is okay there. Yeah, I think it's good. I should hopefully, huh? How should I do it? On the thread? So, we are now connected. 33120. So, Lal, if you can increase the voltage, I just want to check the temperature, which is a very important element.
Can I put directly 399?
Put a 350 for now.
Then
So what do we have? 331.
yeah.
Put 360, and then we want to see how we're getting there. So what is very critical is making sure that we don't have excessive temperature increasing, especially on the connectors, which could be a bad connection. But so far, everything looks good. So 332, we can see that it starts increasing. Go to the temperature. So this is the screen that we're monitoring constantly. We expected that we're going to have a few good hours while this is charging, but we are making progress. The charging of the second battery, it is complete. Now let's do a double check, Lal. So let's measure with the multimeter, make sure that indeed the charge is fine. So 399, just a bad connection here. 400. Let's go back to the other one. $399. So we have two batteries, each one 400. Now, one part of the deal is done. The other one is to do with this, not this control unit. So this is basically part of the pack that is working fine. Here is the one that is not working fine. We managed to set up a different connection that we also can read the memories, the memory from that. So let's have a look in here. So we have 400 amps. If you look at the cell status, well balanced, so 20 millivolts. So the battery is in very good condition. And we are going to go back to the module that is actually was working all fine. Just again to see the stats on that. So this is the second battery, the one that was always operating fine, well balanced also as we look to the throughout the cells is good. Now the question is, has anything changed in the memory of this control unit after we've charged the battery up? What was the error code? replace the control unit.
Control unit.
So I said we managed to do a different connection to be able to read the data and have a look what it is here. So high voltage battery module must be replaced. Meaning this. Yeah. So let's recap why we ended up in here. So even with the battery discharge, we had the error. The test plan was saying to discharge the other battery, bring it to the same level, follow procedure with the dealer machine, with the eccentric Mercedes dealer machine. And then it was a process that was talking about, what, 180 minutes it was doing, like he was calculating something. Anyway, both, so we've discharged the good battery on the same level. However, on charging up, the first battery never went up with it. So it looks like that error code is permanently stored in the control unit. So we have to think a bit outside the box. And our strategy, since in that control unit we have no error codes, our plan is to take this unit off and deal with it on the bench, extracting data from the other one, compare it, modify, and write it in here. Well, in theory, this is the plan. And for this, we're gonna call Florin from Car Key Solutions. We're gonna take the units off. Actually, Florin it came here to us to help us with this job. So let's see, this is the plan. And I wanna try something as well, one step at a time. Let's take the modules off and see what Florin can do. Got also the bad one. Florin here has got the good one, and let's hope out of two, we're gonna have two good ones. Not one good, not two bad ones, hopefully. So now it is the time that Florin is going to work the magic. Let's see how it's going to be. So we've got Florin in the house. Here's Florin.
Nice to meet you.
So he did already the magic. Now it is the time to check. So here we have all the error codes before. So the module 1, high voltage battery must be replaced. So we haven't replaced what Florin did, transfer some data from one to the other. We have them connected back to the car, back to the battery, and we are connected. Let's see if this has worked. So this is the old error code. We haven't cleared. What we're gonna do, we're gonna go out and read once again the modules. Let's see if that control unit module has to be replaced, has gone away. That'll be massive for today. We have 14 error codes now. That error is no longer here because we basically taking the data out of the old one. So we have 13 error codes in this module and 14 in the previous one, although in the module 2. So it looks like the error has changed. I mean, obviously we have lots of things disconnected, but on the module 1 we had control unit that has to be replaced. So that error is gone. Obviously we still have modules disconnected, so we're gonna have interlock errors, which is normal. It's not available. Well, it could be because obviously we don't have everything connected. Exactly. So internal communication, yeah, we are aware of that. Obviously we don't have everything properly connected. We have managed to get rid of the control unit must be replaced error. So this was the task. The fact that we have error codes in module 2 is normal. So obviously we have disconnection with the car. We obviously have a lot of signals missing. So I think we are on track because our error, it was control unit has to be replaced, and we never been able to get rid of that. We don't have the balance. Let's see if we have, you know what? The cell voltages in a high voltage battery are different. Well, that is on the main, but they no longer different. Yeah. So far. Yeah. So far, I think It's the most that we can do here. We'll obviously have a lot of error codes due to communication, but I think we might have overcome the biggest problem. I think so. So we no longer have error codes saying the control unit must be replaced. And then because we have so many things disconnected, we still have in the main control unit cell difference, but there's no difference in between them. Yeah, it's stored on the master. We have to put it on now. That's yeah, definitely interesting. But obviously, I didn't expect we're gonna get rid of all the error codes because it's impossible since we are not connected. But we managed to clear that bit of the memory. I think we making progress. Let's see now back on the car. So, Florine, thank you very much, Florine. Let's hope we're not gonna have the battery back on again. But Florine from Car Key Solutions, it's always a call away, always willing to help. He's very busy as always on the phone. And don't forget, Car Key Solutions is the name to call for car keys and vehicle security, and even for ECU programming like this. Definitely our partner to go when it comes to it. But I think we're making progress, slowly but surely. So now we're gonna install everything back. We're gonna call it for the day. We are just before Easter weekend, so we're gonna have a break, and then yeah, we're going to go back to it to put it together and hopefully get finally the EQC running. Still a bit to go, but I think we're making progress. Battery is now assembled and ready to go to the car. It could be that when we're gonna turn the ignition on, this is gonna go to half. Basically, just one battery. Or if it stays like that, we might have the system running. However, we still have an error code. Hold on. This is not very good. This value here is not as good as we expect it to be. Ideally, somewhere around 20 millivolts. Now, is this where everything started?